Hi students, it is me, Ilagovan, teaching zoology for students. And as we have some unfavorable conditions, we cannot teach you directly. So, we are taking videos and just sending you to reach your home so you can just study the lessons, understand the lessons. If you have any doubts, any questions, that will be actually dealt with later. Listen to the lesson carefully. Now today we are talking about genetics. That is a principle of inheritance. What's the meaning for that one? Now, what is genetics? Under genetics, we have to talk about two aspects, or we can say genetics deals with two aspects. What are the two aspects of genetics? Number one, heredity. The two aspects. Number one, heredity. Number two, variations. So these are the two aspects of genetics. So what do you mean by heredity? If you are taking any individual, say an example of dog. The dog is giving birth puppies. The cat is giving birth what is called the kittens. You see, the dog is always giving birth only puppies but never kittens. And similarly, the cat never gives birth puppies. It gives birth only the kittens. So this is what we have, the tendency of individuals to resemble their parents. And that is called what is known as heredity or inheritance. Or the characters are passed on from the parents to the young ones. So, if you are taking any family, there are many individuals, there are many members, and these members are resembling their parents. Any individual, any species. Now what are variations? Take again the dog. A dog is giving birth 6 puppies. All are puppies only. That is what is called heredity. But not all the puppies are similar. One may be black, one may be red, one may have patches of red and white or black and white. See, not all the puppies are similar in their morphology, anatomy, physiology, behavior, etc. Such differences between the parents and the young ones, even among the young ones, is called variation. So, the degree by which the individuals, the progeny or the offsprings are differing from their parents, differing among themselves are called variations. The differences among the individuals are the same species. That means no two tigers alike, no two lions alike. Among the same species, we are considering differences, and such differences are called variations. So these are the two aspects. We'll talk about more about genetics in botany under classical genetics. Now, in this chapter, in your 12th standard biozoology, we have the following topics. What are the topics which are going to deal with in this one? Number one, multiple alleles. Number two, that is what we have sex determination. What are the topics to be covered in this lesson? Number one, multiple alleles. Multiple alleles. Number two, sex determination. Sex determination. Number three, sex-linked inheritance. Sex-linked inheritance. Number four, some disorders related to genetics. So, genetic disorders. Genetic disorders. And number five, we have extra chromosomal inheritance. Extra chromosomal inheritance. And others also. Generally, these are the major topics we have to cover: multiple alleles, sex determination, sex-linked inheritance, genetic disorders, that is extra chromosomal inheritance. So we have to take the first unit, multiple alleles, related to the blood groups. Now what are multiple alleles? What are multiple alleles? Now if we are taking the height of the plant in garden P, height of the plant in garden P, there are two varieties. One, tall, another variety, dwarf. The tall character is normally called as a wild type, wild or normal type. Normal trait. Normal trait. And this one, because of a sudden change, the normal type gets mutated. That's because of mutation we can say. It becomes a dwarf, and that is what's called mutant type. Mutant type. What is mutant type? A normal type, when undergoes mutation, becomes a new type, possibly a recessive one. It's called as a mutant type. The mutant variety is the one which is formed as a result of mutation. So the tall character is a normal trait. The mutant type, there is a dwarf character. Now the tall character is produced by a gene, capital T. The dwarf character is produced by a gene, small t. Generally we can say the expression of the height of the plant is controlled by T gene. Orally we can say T gene. And the T gene, there are two. One is a dominant gene, another one recessive gene. You know, the dominant gene is the one which is being expressed, and the recessive gene is the one which is being suppressed or which is being actually masked, which cannot be expressed, we can say. Now, if you are taking the T gene, now there are two alleles. If you are taking homologous chromosomes, say an example. Now there are two alleles. Suppose you are making a cross between a homozygous tau, a homozygous dwarf. We are getting what is called a heterozygous tau. If you are analyzing the nature of the homologous chromosomes of a heterozygous tau, we have, suppose we can assume the gene for that one is located in the fifth locus. In the fifth locus. Now this is capital T and this is small t. So the gene for height is located, that is in the fifth locus of a particular chromosome. It may be either capital T or small t. In homozygous condition, we have capital T in fifth locus. In homozygous dwarf condition, we have that is small t. But in case of heterozygous condition, they have two alternative alleles, one capital T, small t, but the gene T is located at the same locus irrespective of its type. So here we have, if we are taking the height of the plant, we have two alternative alleles, only two alleles. What is an allele? Alternative form of the same gene. Alternative form of the same gene is called an allele, capital T and small t are allele. Suppose you are taking capital A and small a, these two are alleles. If you are taking, for example, capital B, small b, these two are alleles. So, allele is the alternative form of the same gene. Allele is the alternative form of the same gene. Capital E, small a, capital B, small b, like that. Now, in some cases, if you are taking a particular character, the character is expressed by more than two alleles. Say an example. It is not there in the syllabus, but I would like to give. If you are taking eye color in Drosophila, eye color in Drosophila. You know, this is a common fruit fly having 4 pairs of chromosomes. The eye color is controlled by a gene located in X chromosome. Eye color is controlled by a gene located in X chromosome. Now, in comparison to the height of the plant, where you have only two varieties, two traits, alternating varieties. In the case of eye color, we have more than 8 shades of eye color. Some fruit flies, they have red eye color. Some may have white. Some may have orange. Some may have yellow. Some may have pink. So like that we have more than 8 shades of eye color. Out of these, the red eye color is the dominant character. That is capital R is the dominant character. And all others are recessive characters. When a cross is affecting between a red eye color fly and orange eye color fly, we can get only red. Or with white, we can get just only red. So, red is considered as what we have actually the dominant character. All others are recessive character. Let's assume the white eye color is produced by a recessive gene small r, a mutant allele. Orange eye color is controlled by R1. Then pink eye color is controlled by R2. Yellow eye color is controlled by R3. See here, we have more than 2 alleles instead of 2, capital T and small t. Here for one character, eye color, more than 2 alleles. Eye colors of different types, and each eye color is controlled by a gene. The red eye color is controlled by a dominant gene, capital R. Normally, the genes for eye color are located in the X chromosomes. I am taking 3 individuals, red, white and pink. Now in the case of individual with red eye color, the gene capital R that is located at the locus 6 of X chromosome. I am taking another individual that is white. Now the gene small r, the recessive gene, the mutant allele is present at the same locus 6 but in X chromosomes. And similarly the pink eye color. The genes for pink eye color, let's assume R1. So we have at the locus 6. So we have like this nearly more than 8 shades of eye color. I am taking only 3. So what is the meaning for multiple alleles? If you have only 2 alternative forms, they are called alleles. But here we have the occurrence of more than 2 alleles, or R1 for example, R1, or R2, R3, R4, expressing or encoding different eye colors. So I will come to the what is called the definition. A single gene is being represented. A single gene is being represented by more than one form. Here you can see capital R, small r, R1, R2, R3, R4. So now we'll give the definition for multiple alleles. Occurrence of more than 2 alleles, that is point number 1. Occurrence of more than 2 alleles affecting the same character, that is point number 2. That is eye color. Eye color. Located at the same locus, for example the 6th locus of X chromosome, 6th locus of X chromosome in a population, that is called multiple alleles. Occurrence of more than 2 alleles affecting the same character, located at the same locus in X chromosomes in a population, and such alleles are called multiple alleles. And the phenomenon is called multiple allelism. Multiple allelism. This is the example I am giving. Even if you are taking for example the rabbit, if you are taking the coat color is different in the case of rabbit. It may be just what is called green or white, Himalayan albino, that is black, like that. So, when a single character is being represented by more than one form, or when a single... Okay, let's continue further. So that's the definition. I think you can understand, you understood that one. So occurrence of more than 2 alleles affecting the same character, located the same locus in a population. When more than two alleles are present at the same locus, controlling the same character, then the phenomenon is called multiple allelism, and we have the alleles called multiple alleles. Now this is example not in our syllabus, but for understanding I am giving that one. Let's go for. So the example given in our syllabus, XII-Bio blood system, RH blood system. XII-Bio blood system, the example for multiple allelism in our syllabus given XII-Bio blood group. XII-Bio blood group and also RH blood group. These two are the examples for multiple allelism. Now let's go for XII-Bio blood groups. You have already studied XII-Bio blood system, not based on genetics, only biochemical analysis of blood groups. Now the XII-Bio blood system is normally consists of four major types of blood groups: A, B, AB and O. Now one's own blood group is different from another person chemically. So there are chemical differences between the blood groups of two different persons. The chemical difference is based on the presence or absence of a proteinaceous substance or any other substance, what is called antigen. This is not actually a protein, but somewhat a different substance, glucosamine, a sugary compound, antigen. So one's own blood group is different from another, that is because of antigen. The universal name for antigen is called agglutinogen. When two different blood groups are mixed, incompatible blood groups, incompatible means not matchable blood groups are mixed, then we have a process occurs. The name of the process is called agglutination. The name of the process is called agglutination. We have studied in 11th standard. Now agglutination means clumping of erythrocytes, sticking together, clumping of blood cells. When two different blood groups are mixed, we have agglutination or clumping of blood cells or erythrocytes occur. The agglutination results because of a chemical reaction between two substances. One is surface antigen. This is simply the antigen or surface antigen. This is also called surface antigen. We have studied already the surface antigen is present at the surface of RBC, hence called surface antigen. When opposite antigen enters into the body, it stimulates the production of certain protective proteinaceous substances. These substances are called antibodies. It may also be called agglutinin, having different names based on the function, but generally called agglutin. When opposite antigen enters into the blood, this antigen normally reacts with these antibodies, resulting in what is called agglutination. So, antigen-antibody reaction resulted in the formation of clumping of blood cells, and that phenomenon is called agglutination. So, based on this one, we have just actually made four different types of blood groups. Not we have made, but normally in 1900, Carl Landsteiner, father of hematology, one person what we studied, I already mentioned about this person in 11th standard. Carl Landsteiner observed three types of blood groups. Carl Landsteiner observed three types of blood groups: A, B and O. The classification is based on the presence or absence of antigen or agglutinogen. The major classification of blood groups is based on the presence or absence of antigen or agglutinogen. So he just observed three different types of blood groups. Another blood group, that is AB, the special type of blood group, was reported by two of his students, namely Von D. Castle, Von D. Castle, another person Starling. These were the students of Coleman Steeler. They only just formed the special type of blood group AB. So here, the blood groups are named, I mentioned already, based on the presence and absence of antigen. So in our blood, we have either A antigen or B antigen or no antigen with reference to A. We have either A or B or no antigens in our blood. So people with A antigen in their RBC are called A blood group. People with the B antigen are said to be B blood group persons. And people with both the antigens A and B, they have actually AB blood group. And people without any of these two antigens, either A or B, they are called as O blood group persons. Okay, this is a biochemical analysis, what is studied. And what is studied already last year. What are the corresponding antibodies present in the plasma? So, antigens are present at the surface of RBC. Antibodies, the proteins, protective proteins are found in the plasma. So, the reaction occurs in the plasma, leading to the clubbing of blood cells. We have already discussed this one. What type of antibodies a person with A blood group, what type of actually a person with the B blood group, and what type of antibodies with persons AB blood group and also O. We have a clear-cut actually tabulation the last year and this year also. Now this is the blood group. If you are taking antigen, so antigen is always present in the RBC. Recall what is studied in 11th standard. Antigen A. People with B blood group have antigen B. This is the one I am repeating what I already discussed in 11th standard. People with AB blood group have both antigens A and B, and O blood group no antigen. Now what are the corresponding antibodies in plasma? We discussed already this one. That's why I want to recall that one. So they have anti-B antibodies in the plasma. When B blood group is given to A, clumping occurs. This is because of the antibody B present in plasma, which will react with antigen B present in B blood group. And people with the B blood group, they have anti-A antibodies. And people with the AB blood group, they have no antibodies. That's why AB blood group persons are called universal recipients. They can receive blood from all the four types. Nothing would happen. Even if you are taking the universal recipient, AB positive is the universal recipient, not that is AB negative. I discussed this one. I don't repeat the same one once again. And if you are taking O blood group person, they have both anti-A and anti-B antibodies. Anti-A, anti-B antibodies. That's why O blood group has no antigens. It can be given to anybody. That's why the O blood group is called universal donor. But the two O negative, not O positive. O negative is a universal donor. I mentioned the reasons also because it has no antigens. But it cannot receive blood from anybody except O. The reason for that one, it contains both anti-A and anti-B antibodies. So we cannot donate blood to O, but O can be donated to all. The reason for that one, because of the antibodies A and B, it cannot receive. Because of the absence of antigens, it can be given to anybody. So this is the biochemical analysis. We have studied in 11th standard. I am repeating the same one. And what is the basis? What is the genetical basis for this one? Let us discuss in detail, okay, in the next class.